In this video, we're going to divide a polynomial by a monomial. So many terms divided by one term. Let's start with this example. 16 x to the fifth plus 12 x to the fourth minus 20 x to the third. Hey, why not? Let's keep going. Let's do one more. Plus, how about 8x squared? And we're going to divide this whole thing by 2x. So the key to doing this problem is to realize you're dividing the whole thing by 2x. What I see the biggest mistake is where people would take and cancel this 2 with this 20 or this 2 with this 12. Well, you can't do that because every term is supposed to get divided by 2x. So the way you want to think about it, here's you thinking. Here's how we want to think about this problem. We want to think I have to take 16x to the fifth and divide it by 2x. And then I got to take 12x to the fourth and divide it by 2x. And then I got to take 20x to the third and divide it by 2x. And I got to take 8x squared and divide it by 2x. Every single term by 2x. So really, you're just broken down this problem into 4 smaller problems. So let's go off to the side here and look at this first problem we're going to do. This 16x to the fifth over 2x. Well, you got to remember 16x to the fifth. What does x to the fifth mean? X times x times x times x times x. That's what x to the fifth means. So what are you going to do when you're dividing? Well, you can cancel, or you could just divide. 16 divided by 2 is 8. Or you could think about canceling this 2. 2 goes into 2 once. 2 goes into 16 8 times, whichever way. Now what about the x's? I mean, the 16 divided by 2, that's the easy part. What about the x's? So what can I do here? Well, I can cancel one of these x's. I can cancel 1x on the top with 1x on the bottom. And what does that leave me up here? X times x times x times x, or x to the fourth. So my answer for 16x to the fifth over 2x is 8x to the fourth. That's just this first part. Now before we leave this, let me remind you that there's a rule that says something like, oh, you might see it as a to the m over a to the n equals a to the m minus n. It's telling you to subtract these exponents right here. That is the shortcut, and that's exactly what we did up here. We had a 5 for an exponent on the top and a 1 for an exponent on the bottom. So 5 subtract 1 is 4. And that will work every time. You really want to be careful though. Let me erase this and show you a quick example that has nothing to do with the problem that we're doing, but highlights when to use this rule. You want to be careful. Let's say you had something like 8x to the 8th over 4x to the 4th. This doesn't have anything to do with the problem we're doing, okay? I just made this up. This is totally separate from what we're doing, but I just want to highlight here. This 8 and the big 8 and the big 4, those are coefficients. So you're just going to treat them like a regular 8 and a regular 4. 8 divided by 4 is 2. This little 8 and this little 4 are exponents, so they work under different rules. This rule right here, that's the rule they work under. 8 subtract 4 is 4. So notice, even though we started with a problem where we had 8s in the top and 4s in the bottom, we come up with 2 different numbers in our answer, the 2 and the 4, because we treat these numbers differently if they're coefficients or if they're exponents. So that's something you really want to keep in mind when you're working with these problems that involve exponents. Alright, let's get rid of all this and go back to the problem we were doing. And we're going to do the next part, which is 12x to the fourth over 2x squared. So based on what we just did, we could probably figure this out here. I'm just going to bring the plus down. 12 divided by 2 is 6. And I got an x to the fourth over an x to the first. So I can think about subtracting those exponents, or I can think about canceling one of the x's. And either way you think about it, hopefully you're thinking you have x to the third left. Bring down the minus. 20 divided by 2 is 10. Now I got an x to the third divided by an x to the first. If there's no exponent there, it's to the first power. And I'm going to subtract those and get x to the second. And lastly, 8 divided by 2 is 4. And x squared divided by x squared divided by x, remember that's x times x over x. One of those x's is going to cancel, and you're just left with an x. I'm left with 4 terms here, and none of these terms are like terms because all the exponents are different, so I can't combine them together, and I am done. My answer is 8x to the 4th plus 6x to the 3rd minus 10x squared plus 4x, and that's the answer to the question. Let's do one more example that has a little bit of a twist. Let's say we have something like, let's see, 16x to the 5th minus 20, I'm using some of the same numbers again, but that's okay, x to the 2nd plus 4, let's do 24, x, and we're going to divide that whole thing by 4x squared. Now some of you are probably thinking, based on the last example, okay, I can do this in my head now. I see I have to divide each term. But I would suggest just taking the extra minute. You can time me here and see how long it takes me to write this step out. Just take the extra minute to write out that you're going to actually divide each term in the numerator by that term in the denominator. What'd that take? 20 seconds? I don't know. I didn't time myself. That will avoid making little mistakes, and it breaks down this problem into smaller problems that you can just chew one bite at a time here. So here we go. 16x to the 5th over 4x squared. 16 divided by 4 is 4. X to the 5th divided by x squared. We could use our subtracting rule, and 5 subtract 2 is 3, so I get x to the 3rd. Or we could have thought of it as x to the 5th. If you're not sure, write it out. There's x to the 5th over x squared. You can cancel 2 of them, and you're left with x to the 3rd. Perfectly good way to do the problem. All right, next step, 20 divided by 4 is 5. Now I got x squared over x squared. If I use my subtraction rule, I actually come up with x to the 0. 2 subtract 2 is 0. What is x to the 0? Where there's a rule, and you can look this one up if you haven't seen it, anything to the 0 power is 1. Anything, that's kind of weird, but that's the rule. Anything to the 0 power is 1. And there's a reason for that has to do with the rules of exponents that I'm not really going to get into in this video. But you could look it up and see if you're really curious. So if I had a whole bunch of junk, 2x to the 5th, y to the 6th, z to the 10th to the 0 power, that would be 1. Anything to the 0 power is 1. If you were to write it out the way we did, where you wrote everything out and then canceled, x squared over x squared, that's kind of an easier way to think about it. You've got x times x over x times x. Well, they cancel out. X divided by x is 1. 1 over 1. X divided by x is 1. So I end up with 1 over 1, which is just 1. And 5 times 1 is just 5. So you don't have any x's here. You don't want to write x to the 0. That's just 1. 5 times 1 is 5. So don't even write it. They cancel out. They're gone. Those x squareds cancel out. They're all gone. Okay, last step. We're almost done. We got to do 24x over 4x squared. Now I'm going to write this one out over here because something a little different happens. In that subtraction rule that we had, where we had a second ago, a to the m over a to the n is a to the m minus n. Notice we had to take the top exponent minus the bottom exponent. This one, your top exponent is smaller than your bottom exponent, so you'd end up with a negative number. There's another version of that rule which says you could also do if you have a to the m over a to the n, you could write that as 1 over a to the n minus m. Notice here I've got the n first. I'm doing n take away m, and it's going on the bottom because the n is first, where the other rule, the m is first, m take away n, and it's going on the top. There's no fraction, but it would be on the top. And you would usually do this first version here, we'll call this version A, if the top exponent was bigger than the bottom exponent, and you'd do this version B if the bottom exponent was bigger than the top exponent. So what you really want to do is the bottom 2 take away 1. all these rules, sometimes they can get a little weird. This is where writing it out, 24 over x and 4 over x times x, just kind of makes more sense. It's a little more visual. You're still going to cancel out one of these x's. Well, where's the x that you have left? It's in the bottom because you started with more x's in the bottom. So, of course, if you have any left over, they're going to be in the denominator, in the bottom. The 4 and the 24 we're going to treat the same way. 24 divided by 4 is 6, and that's going to go on the top. So when you write your answer, you're going to have to write a fraction. It's going to be 6 over x. And using this rule would work. You would go, for your rule, for your exponent, you'd go 2 take away 1 is 1, and then you'd have to put your answer on the bottom because your bigger exponent was on the bottom. If the rule works for you, great. Use it. If it's a little confusing, think about the canceling and that, and you can, without even writing it out, you can almost visualize what's happening with the canceling and be able to determine, whether your answer is going to go in the numerator or the denominator. But if you have a bigger exponent in the denominator and you're canceling, your answer is going to go in the, you're going to have some x's left in your denominator or y's or whatever you're working with. Alright, so that's it. We're done with that problem. We ended up with 4x to the third minus 5 over, or plus 6 over x. No like terms. Can't simplify it. I'm all done. Again, I really encourage you to take this step right here to write that out, avoid those little mistakes, and conquer these problems.